This is Cycle 3, Lesson 9. We just finished in our last lesson solving rational equations, and now our logical next step is to look at solving rational inequalities. We're going to use techniques that we've used before. We used the same techniques when we were solving polynomial inequalities. It's always the same techniques, we're just applying them to different types of functions. So there's probably a few specifics that we need to consider for rational functions, but really it's just picturing how the graph's going to look and helping us to divide things into intervals. If you remember from the polynomials functions that really we wanted to look for things like asymptotes. I guess there weren't a lot of asymptotes for polynomials, but also x-intercepts. Asymptotes and x-intercepts are what's going to help us decide whether something's above or below the x-axis. Now remember, we had two ways of solving inequalities. Again, we had the one where we did both sides of the equation, left side and right side, as separate functions, seeing where one function was above or below the other one. Or we could have the whole equation on one side, letting it equal or be greater than or less than 0, and then just looking for above or below the x-axis, which is usually the easier way if possible. Anyway, let's do two examples, a fairly simple one and a more difficult one, and then just sort of see what comes out. So if we're asked to solve 2 over x minus 5 is less than 4, don't worry about the highlighting for now, that just pertains to a graph that I don't want to really reveal yet. Let's just solve. This is an easy enough one to solve. We could try to solve it by cross-multiplying, just making sure that we follow the rules of solving when we've got inequalities here. So if I cross-multiply, I get 2 times 1 is less than 4 times x minus 5. All right? Remember, the only thing I have to watch out for when I'm solving inequalities algebraically is if I multiply or divide by a negative number, then I need to change the direction of the inequality, but that wasn't the case here. So carrying on, if I do distributive law, I get 4x minus 20, and then if I want to isolate x, then I'm going to subtract 20 from each side, and add 20 to each side. So in minus 20, it becomes positive when I bring it to the other side, so I end up with 22 is less than 4x. Divide each side by 4. Again, I'm not multiplying or dividing by negative numbers, so that's okay. I don't have to do anything special. I get 5.5. I get x is greater than 5.5, which sounds good, right? It sounds like a reasonable answer. But now let's take a look at the graph. I've pre-sketched it so we can see it. So I did the technique where I sketched 2 over x minus 5 in green. It's got a vertical asymptote at positive 5. It's got a horizontal asymptote at y equals 0. You can see there's two portions of the graph. And then I graphed the other part, y is equal to 4 as its own function. It's just a horizontal line through the point y equals 4. If x is greater than 5.5, okay, that makes sense because it takes into account our point of intersection. This is the point of intersection, 5.5, 4. And we want to know when the green graph is below the blue graph because it's less than. When the green graph is less than the blue graph, that's going to give us our solution. So yeah, we're going to start at 5.5. We're not going to include 5.5 because it's not an or equal to sign, it's just a less than. So anywhere on the x-axis from 5.5 over is going to give us our solution. However, that's not the end of the story. We can clearly see from looking at the rest of the graph that all of this part of the graph here is below the blue graph, right? That is definitely less than 4, what I just highlighted there. And that wasn't, we didn't get that when we solved it algebraically. So our full solution is actually going to be x is greater than 5.5, and x is less than 5. So I guess the rule that we want to keep in mind is, this is a special case. If one fraction is less than or greater than a number like 4, there's always going to be something like this going on. So we should check it graphically. We should always look at the graph, because there's always going to be something like this happening. So from the graph, we also know that x is less than 5. So that's one specific thing that we have to look out for when we're dealing with rational functions. The other example we're going to do is a more complicated looking one, but in some ways it's more straightforward. It's going to ask you to go back and think about the table that we've used before. So if you don't remember the table, let's just see if I can dig it up. I think I've moved some stuff around. Solving. Is this it? I think this might be it. This is it. In lesson, cycle 3, lesson 5, remember where we found the zeros, and the zeros broke a graph up into sections, and then we wanted to know where the graph was above for greater than or below for less than when we were solving our polynomials. So we're going to use something similar to that. But in this case, we're not just going to look at zeros, we're also going to look at asymptotes, because we know how asymptotes divide up a graph. We also know that when we're dealing with rational functions, we want to have things in factored form. So I'm going to rewrite this in factored form. That's supposed to be an arrow. And so the top factors as x minus 2 times x plus 1. The bottom factors as x plus 4 times x minus 3. Quick check, there's no common factors between the numerator and the denominator, so no holes going on here. And so this is greater than or equal to 0. So if I were to graph this, I'd look for the part that is above the x-axis. But I'm not. I'm going to solve it algebraically. From this, we can see that the vertical asymptotes are x equals negative 4 and x equals positive 3, right? I'm looking at the denominator to get my vertical asymptotes. The x-intercepts are going to give me some more points I need to consider. So from the numerator, I can get my x-intercepts, and those are going to be x equals positive 2 and negative 1, setting those ones equal to 0. Anything else? We could, if I was graphing it, I could look for the y-intercept, I could look for the horizontal asymptotes, but none of that really matters at the moment, because really all I care about is where's the graph going to be above the x-axis, where's it going to be below the x-axis. And with that, I can use the table that I was, like the one I was just showing you a second ago. So remember, when we set up the table, we divided into columns. And so, well, let's just draw a little bit of the graph, not the actual graph, but just those points on the graph. So I'll just make a small version of it over here. So we had vertical asymptotes in -4 and +3, right? So let's say this is -4, and this is +3. And we got x-intercepts at +2 and at -1. So the graph is going to cross the x-axis at the intercepts. It can't go beyond the asymptotes. Hopefully it's clear that we've got one section of the graph here to the left of -4. We got another section between -4 and -1. We got another section between -1 and +2. Got another one just between 2 and 3, and then one more between, well, greater than 3. So again, think of the intercepts and the asymptotes as dividing lines between sections of the graph. And you can see how I've thought of it as 5 different sections. So I'm going to need 5 different columns for my table. And each one of them is just going to match what I just said. So I'll have a column that goes to represent the area that's less than -4. And then I'll have another one where x is between -4 and -1. And between -1 and +2. +2 to +3. And finally greater than +3. 5 columns. And then the rows are going to be, remember what, I'm trying to decide whether things are positive or negative overall. So what I need to consider is all the different factors that are involved. So I've got x minus 2 and x plus 1. I don't have to have brackets around this, but I've started, so I'll keep it like that. That's for my numerator. Those are my 2 factors of my numerator. I could even divide it up if I wanted to. I don't need a line here, but that might help me see, all right, that's my numerator. My denominator, I had the 2 factors, x plus 4 and x minus 3. And then what I wanted to know was overall, is for each section of these 5 sections of the graph, again, 1, 2, 3, 4, 5. For each of these 5 sections of the graph, are we above the x-axis or are we below the x-axis? So remember, all we did was we picked a point, and then what we did is we found whether our value was positive or negative for the point. So all we had to record was the plus or minus sign. So for x less than -4, so we just pick some number less than -4. Let's say we pick the number -5, okay? So -5 is indeed less than -4. What happens if I put -5 in here? Well, I get -7. So in other words, I get a negative value. And it doesn't matter if it's -5. Think of any number less than -4. I hope it's obvious. I'm always going to get a negative value. Same with any value less than if I put it in here, -5 or any number less than -5, I'm still going to always get a negative number out of it. So that one's also negative. Any number less than -4, when I add 4 to it, is still going to come up as a negative, right? If it's less than -4, if it was equal to -4, I'd get 0. But if it's less than -4, I got to get negative here. And also if I put it into x minus 3. So all of these turned out negative. Overall, if I want to think about it this way, these two factors were my numerator. Negative, so if I have a negative number times a negative number in my numerator will turn out positive for any number less than -4. Likewise, my denominator, if I have a negative times a negative, whatever number I put in there my denominator will turn out positive for any number less than -4. So then if I think about a positive number on my numerator divided by a positive number on my denominator, it's always going to turn out positive overall. So what I know for certain is it doesn't matter what the number is, as long as x is less than -4, the graph is going to be above the x-axis at that point. And we're looking for places where the graph is above the x-axis, right? We're looking for greater than. So the way I can interpret this is one of the sections I want. So the solution, I could jump to this, is that x less than -4 is part of my solution. Let's go on and look at some other parts. So if I pick a number between -4 and -1, let's pick -2. Actually, let's not pick -2 because that one's... Oh yeah, -2 would work. Sorry, I was thinking +2. So -2 is going to give me negative. -2 on this second row will give me negative. Again, overall, I'll get positive for the numerator. If I put -2 into x plus 4, I get a positive. And if I put into x minus 3, I get a negative. Overall, a positive times a negative will give me a negative, and then a positive over a negative will give me a negative. So overall, this section of the graph is going to be below the x-axis. So we don't want that part. Between -1 and 2, let's pick 0. That's an easy one. What we get is negative, negative, positive, negative. Interesting. When I do that, all right, I realize I was thinking that didn't turn out the way I expected. I realized I made a small mistake. It's not going to affect a lot of things, but I've got to be very careful of being careless. This should have been an x plus 1, shouldn't it? Double checking though, this should have been a positive. But even if I backtrack and check, where I went before, if I put -4 into here, this would still be negative. If I put -2 into x plus 1, this would still be negative. But if I put 0 into x plus 1, this one turns out positive instead of negative. So pardon that little mistake I made. And if you'd noticed it a long time ago, you're probably feeling happy that I corrected it. But what we can see is we got negative positive on the numerator, which is going to be negative overall. We got positive negative, which is also going to be negative overall. But then we do negative divided by negative, we're going to get positive. That means this is, again, above the x-axis. This is going to be part of our solution. So when x is between -1 and +2, that is also part of our solution. Okay? Between +2 and +3, let's just pick 2.5. Well, then we get positive, 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 negative. Positive for the numerator, negative for the denominator, negative overall, not part of our solution. Anything greater than 3, okay, let's pick 4, positive, 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 positive. Everything's positive. That means the numerator and the denominator are each positive. That means that anything where x is greater than 3 is going to be above the x-axis and therefore part of our solution. If you wanted to graph this on Desmos, if you wanted to graph this, where is it? This function here on Desmos, you would see what we just figured out algebraically. It's just another way of tying together what we know, putting what we know from the numbers together with the graph. And of course, they should always match up.